This is the circuit diagram of ratio detector. At first place, it looks similar to the Foster-Seeley discriminator, but we have to note down the differences. The first difference is the polarity of diode D2. It is opposite than in the Foster-Seeley discriminator. Also note down the polarity of V02 across R3. Again, it is exactly opposite than the Foster-Seeley discriminator. A large value capacitor C9 is connected across R2 and R3. This capacitor charges to the peak voltage available across L2. Now, the operation of ratio detector is similar to the Foster-Seeley. Means as the frequency of FM signal changes, the V01 and V02 changes. At the frequency of FM signal Fc plus del F, V01 is greater than V02. At frequency of FM signal Fc minus del F, V01 is less than V02. But at these frequencies, the addition of V01 and V02 remains constant due to the initially charged capacitor C9. This initially charged capacitor C9 removes voltage variations in output. This is advantage of ratio detector. It does not require limiter for uh, to remove the voltage variations. The next difference is the where output is taken. The output is taken in ratio detector at point P and point Q. So V0 out is equal to V01 upon V02. In ratio detector, addition of V01 and V02 does not changes with the FM signal frequency, but ratio of V01 and V02 changes. This is ratio detector. Phase discrimination using phase lock loop PLL. Before going into the details of PLL method, we have to understand basic operation of PLL. PLL content phase detector, low pass filter, amplifier and voltage controlled oscillator. When no input is applied for PLL, local oscillator generates local oscillator frequency F0. When no input is applied, this F0 is called as a free running frequency of PLL. When input frequency Fin is applied to the phase detector, the phase detector or phase comparator compares the phase between Fin and F0 and generates the error signal. This error signal contains two frequencies. One is Fin minus F0, another one is Fin plus F0. Local low pass filter allow to pass only low frequency, that is Fin minus F0. After the amplification, this error signal voltage is applied to the voltage controlled oscillator. Based on the value of applied input voltage, voltage controlled oscillator generates new local oscillator frequency, let us say FO dash, and this process repeats till error signal between input frequency and local oscillator frequency becomes zero. Now we have to study that how PLL is used for the FM demodulation. PLL method for FM demodulation. When no input is applied to PLL, it is operating on free running frequency, that is F0. This F0 is the center frequency of the PLL. When FM signal is applied to input, then PLL start tracking or comparing input FM signal frequency and local oscillator frequency and generating equivalent voltage at its output proportional to phase difference between FM signal frequency and local oscillator frequency. This is demodulated signal. More detailed operation of PLL can be understood with the help of PLL characteristic. PLL operates in three stages. First, in free running mode, second, in lock mode, and third, in capture mode. So as mentioned earlier, for no input signal frequency, PLL operates in free running mode and generates the frequency F0. It is the center frequency of the PLL, as shown by the point O on PLL characteristic. In PLL characteristic, on x-axis we have the frequency, on y-axis we have equivalent output voltage. Now we can see on PLL characteristic that from point A to point B, it is a lock range for the PLL. From point C to point D is the capture range of the PLL. Point A, B, C and D, these are the frequency points on PLL characteristic. We will understand operation of PLL on forward pass of input signal frequency, that is when input FM signal frequency increases from some lower value to higher value, and on backward pass of input signal frequency, that is when input FM signal frequency decreases from some higher value to lower value. We will try to understand operation of the PLL on forward pass of input signal frequency. If the input signal frequency is less than point A, PLL does not compare input signal frequency and local oscillator frequency. Once input signal frequency crosses point A, PLL starts tracking input signal frequency. Means it compares input signal frequency and local oscillator frequency. When input signal frequency reaches to point C, PLL starts capturing, means it starts capturing equivalent proportional voltage available at output terminal as demodulated signal. PLL remains in locked mode till point B. We can see that when the input signal frequency is equal to the center frequency of the PLL, the equivalent output voltage is 0. When input signal frequency crosses point B, PLL come out of the lock stage and stop getting the output voltage. On backward pass of input signal frequency, if input signal frequency is greater than point B, PLL does not track the input signal frequency. Once input signal frequency crosses point B, PLL starts to track or compare input signal frequency with local oscillator frequency. When input signal frequency reaches to point D, PLL captures equivalent voltage available at output terminal as demodulated signal, and PLL remains in lock mode till point A. When input signal frequency crosses point A, PLL comes out of the lock stage and stop getting the output voltage. PLL characteristic on forward pass and backward pass of input signal frequency can be shown together as on the slide. Input signal frequency must enter lock range of PLL for tracking the input signal frequency, and input signal frequency must enter the capture range of PLL to start capturing the output demodulated signal. Takeaway from today's lecture: phase difference between unmodulated carrier and FM signal is encoded as proportional voltage variations in Foster-Seeley detector and ratio detector. In ratio detector, addition of V01 and V02 remains constant due to large value capacitor in circuit. Large value capacitor removes voltage variations in output. In PLL method of FM demodulation, input signal frequency should enter capture range of PLL to get equivalent output voltage as demodulated signal. Thank you.